Hey, good afternoon. Sorry I'm a couple minutes late. Is what? No. Here we go. Okay. Just get this ready. Okay. I think we're pretty good. So, leaving off from yesterday, we practiced solving regular systems again. Then we started talking about nonlinear systems. So systems that have like this x squared, y squared in them. Okay, we did one by substitution, and we did one solving by elimination. So kind of the same idea as elimination that we've done before, but now we'll probably end up with multiple solutions. Could be 1, 2, 3, or 4. All right, and this usually involves factoring. Okay, since we have these squareds in these problems, it ends up that if we have an x squared or a y squared in it or something, we're going to have to factor. Okay, so let's just try on a next example here. Right. So 2x squared, well, I won't read the whole thing, but I'm looking at these two equations, and I'm first trying to decide which would be the best variable for me to eliminate. So I can either choose the x's, eliminate the x's, or the y's, eliminate the y's. I think in this case, the better choice would be to eliminate the y's, because I can see that I could get both of them together. I guess plus 12 minus 12 plus 1 minus 1. So I think if I don't even need to multiply by anything. I think if I just go ahead and add these two equations together, that I'll be good to go. So 2x squared plus x squared, 3x squared, 0, 33x plus 12x, so plus 45x. These y's would cancel, and then 99 plus 63 plus 162 equals 0. So now we want to try to solve this, and hopefully we can factor it. So I think both of these have all three of these terms have a GCF of 3. So let's factor out a 3 first before we try to do any other factoring. So 15x plus, I don't know about this one, 54. Oh, that makes sense. So I have this. Factoring x squared plus 15x plus 54. So that's x plus 9 times x plus 6. Late again, I know. I was also late. I was like 2 minutes late, so you win. I tried to help you out by being late myself, but you still couldn't make it in time. Equals 0. So we set each of the factors equal to 0. Now remember, if we took the 3 and set it equal to 0, that's nonsense. 3 is not equal to 0. So instead, we'll just look at each of these factors. So I'd get x plus 9 equals 0, x equals negative 9, and x equals negative 6. Working on your art project, that's a good enough answer. I'm okay with that then. Now for each of these x values, we have to plug them in to see what the y value is. Now maybe it ends up being the same y value when we plug in both of these, but maybe it ends up being different. We don't know. So let's try. I'll go ahead and plug it into this second equation because why not? We can choose either one though. So x squared negative 9 squared plus y squared plus 12 times x plus 12y plus 63 equals 0. So now just do the actual arithmetic. All right, negative 9 squared, 81. Uh, 12 times negative 9, so minus 108, plus 12y, plus 63 equals 0. I just want to combine all these like terms, 81 minus 108 and 63. So that would become y squared plus 12y. Let's see, 81 minus 108 plus 63, 36. Equals 0. Let's factor this. So that would be y plus 6 times y plus 6 equals 0. So for both of them, I would just get y equals negative 6. I don't need to write it twice. There's no use in doing that. So we know now if we plug in negative 9, the y value that we get is negative 6. So that's one of my solutions for sure. Okay, but I have more. Let's use this. Because now I have to go back through and plug in x equals negative 6 and see what happens. So I'll plug it into the same equation. So negative 6 squared plus y squared plus 12 times negative 6 plus 12y plus 63 equals 0. Move this out of the way. Again, we can plug it into either one of our equations. Doesn't matter which one. And let's just do the arithmetic. So 36 plus y squared, right, minus 72 plus 12y plus 63 equals 0. (36 minus 72 plus 63). So we get y squared plus 12y plus 27. And we need to try to factor this now. So two numbers that multiply to make 27 but add together to make 12. So that would factor into y plus 9 and y plus 3. Solving each of these equal to 0, I'd get y equals negative 9 and y equals negative 3. Okay, so on this last one, we just got one answer of y equals negative 6, but now I have two answers. Whenever I plug in negative 6, I get two separate answers. So I have the point negative 6, negative 9, but I also have the point negative 6, negative 3. Right? We get two y values. That's why there's two of those pink points. And these 3 points should be my solution. All right, let's confirm and look at the graphs. See what this looks like. Let me pull it up. Okay. So our original equations, we had 2x squared minus y squared plus 33x minus 12y plus 99 equals 0. So that's a hyperbola. Let's check out this next one. X squared plus y squared plus 12x plus 12y plus 63 equals 0, which is a circle. So I end up with, we can see here how there's 3 points. Remember, these graphs represent, or the solutions represent, where do these graphs intersect, the curves. -6, -3, -6, -9, and then this point right here is -9, -6. So those are exactly the 3 points that we found. That's what they represent, is where these curves would intersect on a graph. Oops, spilled water all over my desk. So a potential of getting 3 solutions. And let's look at our last example. So again, we can choose whichever variable we want to eliminate. There's usually an easier choice, whatever sticks out to you, but you can typically go either way. So looking at these, again, I see that I have just plus y squared plus 16y plus 16y. It's probably going to be easiest to eliminate the y's because I just need to make one of these equations negative. So I'll multiply this first equation by a negative. So -x squared plus y squared minus 4x plus 16y plus 58 equals 0. This second equation, I'll just copy it down exactly how it was. And now we'll add them together. So 7x squared oops. This would be minus y squared. I didn't change any of those numerators, did I? Or any of those first equation signs, did I? What the heck? All right, so I multiplied by a negative. So all of these signs should change. So minus y squared plus 4x minus 16y minus 58. All right, sorry about that. So y squareds cancel. 4x plus negative 32x, negative 28x, negative 16y cancel, minus 58 plus 23, so that would be minus 35, equals 0. And we'll look at these 3 terms. I see they have a GCF of 7, so let's factor out a 7. Leaving me here. X squared minus 4x minus 5, we can factor into x minus 4 times x minus 1. Not minus 4, minus 5 and minus 1. Man, I'm really struggling today. It was all because Caitlin was late to class. So I get x equals 5. X equals 1. Again, we don't do anything with this 7. But I need to take these x values and plug each of them in individually to one of these first 2 equations. So let's first take x equals 5. Let's plug it into the first equation, because why not? So 5 squared plus y squared minus 4 times 5 plus 16y plus 58. Yes, it should be x plus 1. Maybe I should just stop. Maybe I should just stop. I'm not doing so hot today. Yes, x plus 1. So then x equals negative 1. Jeepers, man. Okay, come on. Come on, man. Pull it together. Oh no. I already didn't pull it together. Alright. Let's see. Did I enter this correct? X squared, 5 squared plus y squared minus 4 times 5 plus 16y plus 58 equals 0. Alright. So 25 plus y squared minus 20 plus 16y plus 58 equals 0. 25 minus 20 plus 58, so 63. Two numbers that multiply to make 63 but add together to make 16. That would be 9 and 7. I think I'm right that time. Maybe. So I get y equals negative 9, y equals negative 7. All right, so we plugged in 5. So when we plug in x, we get 2 distinct y values. Okay, so that means I'll have 2 separate points, 5, negative 9, and 5, negative 7, as 2 of my solutions. And now we're going to go through and plug in x equals negative 1 and see what happens there. So again, let's just choose the first equation, negative 1 squared plus y squared minus 4 times 1 plus 16y plus 58 equals 0. Negative 1 squared is 1 minus 4 plus 16y plus 58. Nope. 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 I screwed up again. I screwed up again. Positive 4. Yeah, exactly. Positive 4. Right, because minus 4 times negative 1, positive 4. So y squared plus 16y plus 63. I know. I'm sorry. I didn't get much sleep last night. I was too busy up playing Fire Emblem. I couldn't even say it with a straight face. Damn it. I don't know. I don't know what's going on. Okay, but we see this is the same thing we got over here. Y squared plus 16y plus 63. So that means we're going to end up at y equals negative 9 and y equals negative 7 again. So this is not technically a repeat because this is what we got when we plugged in negative 1. So I know if I plug in negative 1, I'll also get negative 9 and negative 7. All right, so these are my 4 solutions. It just so happens the y values do turn out to be the same thing both times, but they come from different x values, so it represents different points. Okay, so let's look at the graphs. Get rid of these. And let's do x squared plus y squared minus 4x plus 16y plus 58 equals 0. 8x squared plus y squared minus 32x plus 16y plus 23 equals 0 as well. All right, so we can see here that this is an ellipse and a circle that are intersecting. And we can see they intersect in 4 points. What are those points? I'll give you one guess. -1, -7, -1, -9, 5, -7, and 5, -9. It's exactly the solutions, the points that we found algebraically. Okay, they represent where these points are meeting in the coordinate plane. So just keep this in mind whenever you're taking the PFA or AFA, if you're taking the AFA with this. If you have one of these problems, it's always check all that apply. So even if you solve and you get these first 2 points, you might get excited and go, oh, great, I found those first 2 points, and then you click those and then click submit, but maybe you forgot to plug in -1 to also pick these 2 points. All right, so just be really careful that you're getting everything that you need to.